Okay, in this video I want to do the 5.4 part 1 notes. So we can see on the screen that we have special triangles first. And so we're going to first figure out the missing sides of these special triangles. So that means that for the 45, 45, 90 degree triangle, we've got to remember that this side is A, this side is A, and this side is A root 2. So if that side's A root 2, then that means A root 2 equals 1. So if I divide both sides by root 2 and then rationalize it, I'm going to find that A equals root 2 over 2. So this is root 2 over 2, and this is also root 2 over 2. So if that's not clear to you, then go back and go through your special triangles. Okay, so I think I'm going to try to put this right in here so you see where I got that from. Because down below I want to do the sine, the cosine, and the tan. So remember, whoops, sorry, let me just pen again. Okay, remember that SOHCAHTOA is always playing in the background. So for sine, I'm going to do sine of 45. Since both of the acute angles are 45, I just have to go through that once. So given what we just figured out, the sine of 45 equals opposite, which is root 2 over 2 over 1. And since it's over 1, I'm not going to write that. So the sine of 45 is root 2 over 2. The cosine of 45 is also coming here, root 2 over 2 divided by the hypotenuse, which is 1, so I'm not going to write that either. The tan of 45 is going to be opposite divided by adjacent, which will just equal 1. So make sure that makes sense to you. You may have to stop the video and go back over it. Okay, so now we have another special triangle. We have the 30, 60, 90 triangle. In a 30, 60, 90 triangle, you should remember that the side opposite the right angle, which is the hypotenuse, is the 2A. It's the biggest side. The side opposite the 30 is the A, it's the smaller side, and the side opposite the 60 is the A root 3. So if we know that 2A equals 1, then we know A is 1/2. So if A is 1/2, and the side opposite the 30 is 1/2, and the side opposite the 60 is 1/2 times radical 3, but we're going to write that as radical 3 over 2. Okay, so I'm going to just repeat this over here. I think I'm going to change colors though, so let me do that first. So this is going to be 1/2, and this is going to be root 3 over 2. Okay, so let's first concentrate on the 60-degree angle. So the sine of 60, so from 60 degrees perspective, remember sine is opposite over hypotenuse, it's going to equal, opposite is root 3 over 2, and the hypotenuse is 1. So if you divide by 1, you don't change anything, so I'm done with just root 3 over 2. Okay, the cosine of 60 degrees, cosine is adjacent, so that's 1/2 divided by 1, which is just 1/2, so I'm going to leave that. And then let's do the tan. So the tan of 60 degrees, when we look at that, it's going to be opposite, which is root 3 over 2 divided by adjacent, which is 1/2. So that is root 3 over 2 times 2 over 1. The 2's can cancel, and I'm left with root 3. So root 3 is what I want for tan. And here's sine and cosine. And I'll do the same thing over here. So we have all our values, and this is all based on what's going to be known as a unit circle. Okay, so I'm going to draw a line here. And I guess I'll draw one there. And then let's do all of the three main trig functions pertaining to the 30 degrees. So I'm going to change my color so you can see the contrast. Okay, so from 30 degrees perspective, the sine of 30 is opposite over hypotenuse. So it's 1/2 divided by 1, which just equals 1/2. And then the cosine of 30 degrees equals adjacent over hypotenuse. So that's √3/2 divided by 1. And then the tan of 30 degrees is opposite divided by adjacent. So this is 1/2 times 2/√3. Again, those 2's cancel. I'm left with 1/√3, but I have to rationalize that. So I'm going to get √3/3. So now we have all of our main trig functions as they pertain to the special triangles. Okay, and there's one thing, you can eliminate that extra 3 there. And we're going to go on to the next page. So the next page, the next page just has a table. So look at this table. This table tells us some of the values we've already determined, right? Because here's 30 degrees, and I know the sine, the cosine, and the tan. Here is 45 degrees. I know the sine, the cosine, and the tan. And then here's 60 degrees. And I know the sine, the cosine, and the tan because I just worked that out. Okay, so look at the 0 degrees. Those are new for you, as are the 90 degrees. The other thing that we haven't talked about that you actually know already when you think about it is cosecant, secant, and cotan. Remember that they are reciprocals of sine, cosine, and tan, respectively. So if you just look at those, it'll probably make sense to you. So let's try to answer some questions down here. So I'm going to ask you to give me the answers in both radians and degrees. So you're going to use this table here. So I'm going to use the table. So you're not going to do any really major thinking. You're going to look at the table, and I want radians and degrees. Even though we're going to focus on mainly degrees, for this exercise we're going to do both. So the sine of some mystery angle is 1/2. What is that mystery angle? So go to the table, look up sine, go down and find 1/2, and I'm finding it right there, and then look across to your angles. So it should be either 30 degrees or pi/6 radians. The next one is tan of some mystery angle equals 1. Go to your column that says tan, go down, find the 1, and then go over to your left, and you should be getting either 45 degrees or pi/4 radians. How about cosine theta is √3/2? So look down, and I'm getting 30 degrees when I read over, and this is also pi/6. And then the tan of some mystery angle is √3/2. And again, if I read down my read down my tan, and √3/3 is what I should have said, is going to be 30 degrees or pi/6. So you're going to need to use this table for the homework for number 5. Okay? So you're just reading off the table, and that's all there is to it. And if I ask you for these either trig values or angles, I will give you the table so you're not memorizing this table. Okay, so now comes some interesting things. We are going to talk about symmetry partners. And so I'm going to draw what's going to be known as a unit circle. Let me just do that circle a little bit bigger. Okay, that's much better. Okay, so here's my circle. And now what I'm going to do is I'm going to put my quadrants. So I'm going to draw a line straight through, and then draw another line straight through here, and they're going to meet in the center. So what do you know already? So let me just do that last one again. So what do you know about these quadrants? You should know their names. So this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. So what I'm going to do is I'm going to work on the 37 degrees. So if I give you a central angle of 37 degrees, we're going to talk about some things here. This is going to be your y side because it's opposite the y-axis. This is your x side because it's opposite the x-axis. I'm going to use that same 37 degrees and draw another angle here. This is still y, and it's all positive y's because above the origin are positive y's. Now my x's here are going to be negative, so just take note of that. Okay, I'm just going to work really on the first 2 quadrants only. Now I'm going to grab another color, and when I'm drawing this 37-degree angle, I am starting here and I'm terminating right there. Okay, so that angle's 37 degrees, and its height on the y-axis is y, and its length on the x-axis is x. So those parts of the triangles are x and y respectively. Now if I draw this other angle right here, now it is 37 degrees, but that's only if I just look in that second quadrant. What is it actually? Well, if I kept this blue going all the way, wouldn't that be 180 degrees? So I don't want to have it going all the way. I'm just going up to here. So this blue angle is actually 180 degrees minus 37 degrees, which will become known as the reference angle. Okay, so what angle is that? Well, 180 minus 37 is 143 degrees, which is this angle right here. Now, we could continue doing that in the 3rd and 4th quadrant and get a 37-degree angle, but then figure out what it actually is. And if we did that, we would get 217 degrees and 323 degrees. Now, what I want you to notice is that the reference angles are all going to be the 37 degrees. All right, now look at the sine, cosine, and tan values. They all have the same absolute value. The difference is that some of them are negative and some of them are positive. Well, why is that the case? So let's think about this. So when I want to do sine, cosine, and tan, they are ratios. So I'm going to put another value in this triangle that I've drawn. And that value is the r. So, oops, sorry. Let me get back to where I was. Hang on one sec. Okay. So this is your r. This is your r, the radius, and this is your r. Okay, so let's think about this. Why don't I, for right now, to give myself some more room, I'm going to eliminate this, and I'm going to write down here. So in quadrant 1, what does sine equal? So from angle 37's perspective, the sine of 37 is y over r, because it's opposite over hypotenuse. The cosine of 37 is going to be adjacent, x over hypotenuse, and the tan of 37 equals what? Opposite over adjacent, so y over x. Notice that all of these values are positive. All are positive. And when I say all, I mean the fractions. So this is all quadrant 1. How about quadrant 2? Well, in this situation, why don't we talk about the sign of 143, so we'll actually do the value itself. So the sign of 143 is going to equal opposite, which is y, over hypotenuse, which is r. So they're the same, aren't they? They're both positive. But now we get down to cosine. Cosine of 143, remember that's the actual angle as opposed to the reference angle that we're using from the first quadrant. That's going to be negative x over r. And the tan of 143 is going to be what? Opposite over adjacent, so y over negative x. So what we're seeing now is that cosine is negative and tan is negative. Okay, so let's look over here. So for 143, cosine is negative and tan is negative. So just focus on there. We'll make things more complicated going ahead. But you'll kind of understand it better as we go ahead. So these angles over here are called symmetry partners. Okay, and they're all tied together by the reference angle. So how do we get these symmetry partners? So only focusing on these two quadrants, what I'm seeing is to get those partners, I am going to say 180 minus theta. That gives me the 143. And just really concentrate on understanding these two. Okay, so I got the reference angle of 37. If I subtract that from 180, I will get my actual angle of 143. So what do I know? I know that the sine of 180 minus the reference angle, so in our situation the reference angle was 37 degrees, is the same as the sine of the reference angle. Okay, so this angle was 143. Then I noticed that the cosine of 180 minus our reference angle is going to be the negative of the cosine of 37, which was our reference angle. And the tan, of 180 minus theta, and our theta is the reference angle, so this is 143, also equals the negative of the tan of the reference angle. So this will always hold forever and ever. Okay, these three things will always hold. So what we're going to end up learning is this. Given four quadrants, okay, so quadrant 1, quadrant 2, quadrant 3, and quadrant 4, there is going to be a mnemonic device that's going to help us remember what's positive and what's negative. And that mnemonic device is, let me change color again, all students take calculus. Okay? In the first quadrant, all, so this is all, of the trig function are positive. So every single one, there's 6 of them, remember. In the second quadrant, only sine and its reciprocal partner cosecant are positive. In the third quadrant, only tangent and its reciprocal partner cotan are positive. And in the fourth quadrant, only cosine and its reciprocal partner secant are positive. Okay, so we're going to come to this gradually, but I want to give you a little insight as to where we're going. Okay, so reference angles are always in the first quadrant, and we're going to use them in the other 3 quadrants, and we're going to find there's a relationship between the values of sine, cosine, and tan of those angles. Okay, let's look back at this table again. And we're going to start talking about inverse trig. So inverse trig, in terms of what it is on your calculator, it's what you do. So you take the sine to the -1, that's your inverse trig, of some number is going to equal an angle. Okay, whoops, did it again. So that's the essence of what we're going to be doing, and I'll talk about that a little bit more. But to understand how we're going to do this, let's get some ground rules. All answers are going to be in degrees between 0 and 180, and all your rounding, if needed, is going to be to 2 decimal places. Okay, so listen to this. If the sine of 38 degrees is 0.62, is there another angle in quadrant 2 that also satisfies the sine of 0 is 0.62? So what angle is that? Well, remember, they're going to be symmetry partners. So this is coming later. This is coming later. So don't worry about that right now. Right now, we're going to talk about symmetry partners. And we're only working in quadrants 1 and 2. Okay, so if the sine of 38 is this, there's another angle that's going to be its partner. What is that angle? Take 180 minus 38, and that angle is going to be 142. Okay, with that model, if the cosine of 22 is 0.93, what angle in quadrant 2 satisfies cosine of that theta is negative 0.93. Well, I'm looking for the symmetry partner, because remember, cosine is negative in the second quadrant. So subtract away the 22, and you're going to get 158 degrees. You're going to get things to the whole number right here. Okay, if the tan of 64 is 2.05, what angle in quadrant 2 satisfies that? So I'm looking for its symmetry partner. Take it away from 180, and I should be getting 116. If sine of 154 is 0.44. Okay, now look, this is in quadrant 2. So we want the quadrant 1 angle. Okay, so take 180 minus that bigger angle, and you'll get the quadrant 1 angle. Okay, and the last one, if the cosine of 45 is root 2 over 2, what is the value of the cosine of 135? Well, these will only be the same, and will they really be the same in the second quadrant? It's going to be negative, right? So that is going to be negative radical 2 over 2, provided that 45 and 135 are symmetry partners. So let's test it. Is 180 minus 45 equal to 135? And the answer is yes, and therefore the symmetry partner in the second quadrant will be negative, will have a value of negative root 2 over 2. Okay, so you may have to just think about this a little bit more. Okay, so now we're going to talk about how you get inverses using your calculator. So to this point, we're working with the trig of some angle gives me a value. Well, what does that mean? Well, the trig function is, say, sine. So the sine of, let's say, the angle is 30. That's going to give you a value of 1/2. That's what we've been doing. Okay, so you can use the trig for any of the 6 trig ratios. So that's sine, cosine, tan, cosecant, secant, cotan, right? Angle can either be in degrees or radians, and the value is the output that was returned as our answer. Okay, so now let's work backwards. When you work backwards, it is inverse trig. So instead of saying trig, I'm going to say trig to the -1. That's inverse trig of some value, and that will give me back the angle. So what I'm going to do is I'm going to say the sine to the -1, for example, of not 30, but of a half gives me what angle? That's what I'm doing. Okay? So I could say, I can do it this way too. What angle has a cosine of 0.437? So how would I get that? I would say cosine to the -1 of 0.437. I put that in my calculator. Okay? And that's going to give me an angle. So it's going to return an angle. And depending on whether you're in radians or degrees, that's the type of angle that will be returned to you. What angle has a tangent of 1.46? So in the calculator, you would say tan to the -1 of 1.46, and that would return an angle. What angle has a sine of radical 3/2? You would say sine -1, and then in the calculator, you put radical 3/2, and that would get you an angle. Okay, and whether it's in degrees or radians depends on what your calculator is in. Okay, let's keep going. It turns out that each of the big 3 trig functions have their own respective inverse functions. We will use these inverse functions to answer questions such as, what are the angles in a right triangle that have sides of 6, 8, and 10? Okay, previously we gave you the angles and you figured out the sides. Or question like a 24-foot ladder leans against a house, touching it 18 feet above the ground. What's the angle of elevation that the ladder makes with the ground? In the previous quiz, we gave you the angle of elevation and you had to figure out other things. Identify 2 angles between 0 and 180 that satisfy the equation sine theta equals 0.607. So we're looking for symmetry partners. So all of these things are now doable using inverse trig. So remember, inverse trig looks like this. Okay, so on your calculator, where can you find this? Well, you're going to look at the calculator like that we have over here, and you're going to be hitting your second button. Second sine gives you sine to the -1, or gives you inverse sine. Second tan gives you inverse tan, and second cosine gives you inverse cosine. So this says, I want you to find each of these angles and round your angle to 1 decimal place. So try doing this in your calculator. I'm going to give you the values. So put your mode in degrees, because I want degrees right now. Okay, so mode in degrees, and by the way, because all these values are positive, I'm going to tell you that I want first quadrant angles. So I'm going to give you these answers. Make sure that you can get them. Okay, so if I say to round to the nearest tenth, and you get a whole number of 67, you've got to say 0.0 to indicate that you understand what rounding to the nearest tenth actually means. Okay, so here are your calculator skills. Make sure you can do this. So clearly you're going to need a calculator that does trig functions for this lesson. Okay, so let's keep going. Okay, so now we kind of did a little tease about solving for angles inside a triangle. So we're going to do that now. So remember, read the question carefully. This is SOHCAHTOA stuff. So we're still doing SOHCAHTOA. SOHCAHTOA only works with right angles. So always remember, you've got to be drawing a right triangle. So the 2 legs of a right triangle have lengths 17 and 25. Okay, so draw yourself a triangle. And as I said, it has to be a right triangle. Okay, so I'm going to put my 17 here and my 25 here. And I'm going to label my triangle just so I can refer to the angles with letters. When it says solve the triangle, they want all missing sides and all missing angles. Okay, so that's what solving the triangle means. So let's do the following. I'm going to label this A equals, and I'm going to label these angles that I need. I'm going to go like this so I can see the angles. Okay, so using SOHCAHTOA, let's find a missing angle. So what if I want to use, well, what can I use? If I want to find angle B, so we're going to use this angle first. Okay, so from B's perspective, I have opposite and I have adjacent. So I'm going to use tan. So the tan of angle B equals opposite over adjacent. So therefore, angle B is going to equal what? Well, it's going to equal the tan to the -1 of 25 over 17. Okay, so let's get that. So in my calculator, I say second tan to the -1, I'm in degrees, 25 divided by 17, and I'm getting an angle of 55.8 degrees to the nearest tenth. So right now, I'm going to change this, I guess, maybe to purple. So that angle is 55.8. Okay, how am I going to get angle C? Well, the quickest way to get angle C is just to say 90 degrees minus 55.8. So 90 minus 55.8 is going to give me angle C equals 34.2. So this is 34.2. Because remember, angle B plus angle C has to equal 90. So therefore, if I know angle B, I can get angle C through subtraction. Okay, so that takes care of all of our angles, and I'm going to indicate angles with degrees. So let's get side A. So I feel like using sine. So I can say the sine of, how about if I use 34.2, equals opposite, which is 17, over hypotenuse, which is A. So this is your two-step problem. Okay, so A is going to equal 17 over the sine of 34.2. So 17 divided by the sine of 34.2, and that gives me A equals 30.2. So this is 30.2, and I have solved for the triangle. And solving for the triangle in this case meant finding 2 missing angles and 1 missing side. Okay, so let's go to the next one. Okay, so this problem says from 1976 until 2010, the tallest freestanding structure in the world was the CN Tower in Toronto, Ontario, and it was 553 meters. Suppose at a certain time of day it casts a shadow of 1,100 meters long on the ground. What's the angle of elevation to the sun at that time of day? Okay, so I'm going to draw my triangle. Remember, this is all right angle trig. All right, so what do I have? I'm going to make this an ABC triangle. And what do I know? I am looking for this angle of elevation, and I know that the tower is 553 meters tall, and the shadow is 1,100 meters. So therefore, from this angle's perspective, what do I have? Well, I'm always going to write down SOHCAHTOA so I have it right in front of me. So I have the opposite and I have the adjacent. So therefore, since I have those two, I can use inverse tan to get my missing angle. So I'm going to say the tan of theta equals 553, which is opposite, over adjacent, which is 1100. And remember, you're going to use your inverse tan when you want to get an angle. And my calculator is in degrees, so I'll be getting an angle in degrees. And my angle rounded to the nearest tenth is 26.7 degrees when you put that in your calculator. So that's problem 9. We have a couple of more to do. Okay, question 10 says a 147-foot tall cell phone tower needs to be supported by 2 strong cables. Okay, so let me draw my tower. And then this first cable is here. Okay, so the tower is at a right angle to the ground, and the tower is 147 feet. Okay, so this cable is going to be placed 300 feet away. Okay, I'm going to make this A and this C, I guess. Okay, so then it says also a second cable is going to be placed 200 feet away, and it's going to connect to a fastener located on the tower at a height of 97 feet. So that means that I have another little triangle kind of hanging out in here. And this, so let me write this a little bit better. So from here to here is 147 feet. Okay? And then from here to here is 97 feet. And then from here to here is 200 feet. And then 300 is the whole piece. Okay, so they want to know which cable has the steeper angle of elevation. So here are your angles of elevation. Let's put a B here. Okay, so let's find angle A. So from all of these, I'm going to just get tan because I have opposite and I have adjacent. I don't have any hypotenuses. Okay, so the tan of angle A is going to equal opposite, which is 147 over 300. So that's going to, if I say inverse tan, I am getting A equal to 26.1 degrees. Okay, so right here is 26.1 degrees. Okay, let's find angle B. So the tan of B instead is going to equal 97 over 200. So therefore B equals tan to the negative 1 of 97 over 200, and B is 25.9 degrees. So the angles are pretty close, A and B. But who's the winner? It looks like A is the winner, okay? So this is the largest angle of elevation based on our calculations. Okay, so again, I'm going pretty quickly. You may have to slow down and think about these things. We've got one more problem to do. Okay, so this is a solve the triangle. That means any missing side and any missing angles. So here's our right triangle. So draw your nice right triangle. Okay, so it has one side of length 11. I'm going to put that here. And the hypotenuse is 9. Okay, so let's label this. I'm going to label this ABC. see, this way. And what am I missing? So let's see. I am missing an angle, another angle, and a side. Okay, so let's try to find our missing angle first. So from angle A's perspective, and remember SOHCAHTOA is still playing in the background. So from angle A's perspective, I have opposite and I have hypotenuse. So that's sine. So I can say the sine of A equals opposite over hypotenuse. Remember, we're going to use inverse trig to get our angle. And doing that, I'm so sorry. Hang on one second. Perhaps I should write this number correctly. So sorry, this is a 19. So let me do that and do that. Now that's much better. Okay, so when I put this in my calculator, I get A equals 35.4 degrees. Okay, so here's your A, and it's this one right here. So angle B, remember they are complementary, so angle B will equal 90 minus 35.4, and therefore angle B is going to be 54.6. Okay, so this ends up being 54.6, and this was 35.4. Look at that. I'll just highlight these. Okay, so there we have those two. Okay, so now we have two angles. Let's get the missing side. So what if I wanted to use, well, I can do a couple of things. I can even use Pythagorean theorem. So let's do that for a change of pace. So what does Pythagorean theorem tell us? Well, remember, it tells us hypotenuse squared, 19 squared, equals side squared plus missing side squared. So missing side is going to be the B side. So 19 squared minus 11 squared equals B squared. That's going to give me 240 equals B squared. So B equals radical 240. Now, if I ask you for a decimal answer, you would say second square root of 240, and you would get me 15.5. You would also get me 15.5, and it's going to be meters, if I had you do trig to get it. What if I asked you for an exact answer? Do you remember how to simplify radicals? So if I'm going to simplify radicals, I'm going to take the radical down to its prime factors. So I'm going to start saying 24 times 10. I'm going to go on another page here. And 24 is 6 times 4, and 10 is 5 times 2. 6 is 3 times 2, and 4 is 2 times 2, and then I still have 5 times 2. Okay, what do I do to simplify radicals? Find your pairs. There's a pair of 2's, and here's another pair of 2's. Bring your pairs out as singles. Look what's left inside. Multiply what's outside. Multiply what's inside. That is your exact answer. So this is exact. And this is approximate. So be careful about what we're asking for. If we ask you for an exact answer for a missing side, and you have two given sides, then you probably want to do your Pythagorean theorem. If I ask you for an approximation, you can still do Pythagorean theorem and just get the decimal equivalent, or you can use your trig functions. Okay, so that completes this video. You should now be able to go and look up the homework and do it for this section. So I hope this helped.